Hello, and thank you for joining us on our lecture about basic circuit parameters. Let's start by defining electric charge, which is an intrinsic characteristic of the fundamental particles that make up matter. Charge exists in two states, positive and negative, and is measured in coulombs, which can be denoted by a capital C. In schematics, charge can be recognized as a circle with a positive or negative sign in it, or a lowercase q. There are two ways in which charges interact. The first is opposite charges attract, where one is positive and one is negative. The second is like charges repel, where either both charges are positive or both charges are negative. Next, we will define electric current, which is the change in charge over time. You can think of this as the motion of charge through a circuit. Current is measured in amperes, often referred to as amps, and is signified by an uppercase A. In schematics, a current source is shown as a circle with an arrow, and also the flow of current is shown with an arrow and an uppercase I. Voltage can be defined by the potential difference in charge between 2 points in an electric field. Voltage is measured in volts, signified by an uppercase V. In a schematic, voltage sources will be drawn as either a circle with a plus or minus, or a circle with a sinusoid inside of it. The one on the left is the sign for a DC voltage source. The one on the right is a sign for an AC voltage source. For the purpose of our lessons, we are going to stick with the DC voltage source, which in real life can be equivalent to a battery or DC power supply. Resistance can be defined as the measure of how a material inhibits the flow of current in a circuit. Resistance is measured in ohms, signified by omega. In schematics, you will see resistors shown as this symbol. Now it's important that we discuss passive sign convention, which is when we assume the direction of the current with respect to the voltage of the circuit element. This only works for circuit elements that absorb power, not generate power. One way we can do this is by assuming that the current is entering through the top portion of the circuit element, the positive terminal, and defining the bottom portion as the negative terminal, so it will flow from the top through the bottom. Or we can assume that the current will enter the positive terminal at the bottom of the element and exit through the top negative terminal. The only thing that matters is that we keep this consistent throughout the entire circuit. Now we will discuss Ohm's law, which is the mathematical expression that relates current, voltage, and resistance, and dictates everything in electrical circuits. It is defined as V, voltage, equals I, current, times R, resistance. Ohm's law is often compared to water flowing through a hose, where the voltage is the force that the pump is putting on the water to flow through the hose, the resistance is the diameter of the hose, and the current is the water flowing through the hose. It is also easy to see this example where the voltage can be described as the force that is pushing the current through the circuit. The resistance is the force that is inhibiting the current moving through the circuit, and that the current itself is the actual thing moving through the element. Electrical power can be defined as the time rate of change of energy. Electrical power is measured in watts, which can be signified by an uppercase W. In circuits, power is equal to voltage times current. Or when substituting Ohm's law, power is equal to current squared times resistance, or voltage squared divided by resistance. When power is a positive number, power is absorbed. When power is a negative number, power is generated. Now we will do some simple power calculations, where in this circuit element, 5 amps is entering into the positive terminal of a resistor, and this resistor is dropping 2 volts. That means that this circuit element's power is equal to 2 volts times 5 amps, so the power is equal to 10 watts. And it is a positive number, which means 10 watts is being absorbed in this resistor. In this example, minus 5 amps is entering into the positive terminal of this circuit element, and 2 volts is being dropped over this circuit element. So that means our power is equal to 2 volts times minus 5 amps. So power is equal to minus 10 watts. This means that this circuit element is generating 10 watts of power. Now let's get a little practice using Ohm's law. We have a circuit that has a 5 volt DC voltage source and a 10 ohm resistor. Let's find the current. So we know that we have 5 volts equals I times 10 ohms. This will leave us with I being equal to 0.5 amps. Here's another example. Now we have a circuit with a 10 volt voltage supply and an amp meter reading 0.1 amps through the circuit. So let's solve for the resistance. So we have 10 volts is equal to 0.1 amps times R. This leaves us with R being equal to 10 over 0.1, which equals 100 ohms for the resistance of this resistor. For our last example, let's use Ohm's law to calculate the voltage source. So we know that voltage is equal to current, which is 2.5 amps, times resistance, 10 ohms. This leaves us with a voltage source of 25 volts.